Suppose we consider two signals xt, Fourier series with respect to t naught ak, yt, Fourier series t naught is bk. What about xt convolution yt? First of all, will it be a periodic signal? If we consider two periodic signals and find the convolution of that, will it be a periodic signal? If it is a periodic signal, then only the Fourier series representation makes sense, isn't it? Then only we can find the Fourier series representation. Will it be a periodic signal? Okay, let me give you an example. Let's say 0, 1, minus 1. Let's say this is a periodic signal. Now, if you are convolving this with itself, will it be a periodic signal? Convolving with itself means what? You have to flip the signal first. Since it is an even signal, you will get the same signal. Then you have to slide it, move this point from minus infinity to infinity. Then what?
Periodic with the same fundamental schema.
Is it periodic with same fundamental period?
Yes. Yes, sir, because when we are sliding, it will repeat the same pattern after
It will
every
repeat the
schema.
same pattern, but when you multiply those two and find the area, will it be finite? You take this example, find the value. What is the value of this that convolution at t equals to 0? Multiply these two, find the area. Will it be finite?
No, sir.
No, sir.
No. So convolution of two periodic signals, you always get an infinite, means it is not finite, isn't it? So we cannot say that it is a periodic signal. So for periodic signals, we define a special convolution. It is defined as, this is called periodic convolution. Okay, periodic convolution. Periodic convolution, the definition is, okay, normal convolution, it is xt, x tau, yt minus tau, d tau, isn't it? Is it the normal convolution? And integration over what? In normal convolution? I'm talking about the normal convolution that we discussed earlier. Xt, x tau into yt minus tau, d tau, it is from minus infinity to infinity, isn't it? Forget about this. I am asking about the previous one, what we discussed earlier. It is minus infinity to infinity. And now the periodic convolution, since for two periodic signals, that convolution, it is not a periodic signal. Resulting signal is not a periodic signal. So we can define periodic convolution, that is defined as the operation is same, but you find that integration is over one period. That integration is over one period. So all other operations are same. Flip the signal, move it, find the area. Means in one interval, one period. Okay, then you will get a periodic signal, because this shift is always periodic. The result, you can easily prove that this is always a periodic signal with the same period. Can you tell me what is the periodic convolution of in this case? Suppose this is the integral. This is minus t naught to This is integration over one period. So here it is 4. I am considering that interval as I am considering the integral in area in this window. So what is the operation? You have to flip the signal. Since this is an even signal, you will get the same signal. Now you have to move this from minus infinity to infinity. Since the resulting signal is periodic, always periodic with period t naught, we need to find only the signal for one period. Okay. Suppose I am trying to find the signal in this period. So I am moving this point from here to here. Multiply these two. Find the area in this interval. Is it the periodic convolution operation? Is it?
Yes, sir.
So let us start from here, this point from here, and then move this point to here. Means shift the entire signal. Tell me what is the shape of that? Remember, when you shift this point, this will also be shifted here. The entire sequence is shifting, not only this one. So tell me what is the shape? What is value at 0? This is 1 minus 1. Is it 2? Multiply these two and the area. Is it 2?
Yes, sir.
So will you get a signal like this? 0. Okay, when will that overlap start? What is the value at this point? When this point is here, multiply these two. What is the value? Is it 0?
Yes, sir.
Then what happens? Is it linearly increasing?
Yes, sir.
Then after this, when this point reaches here, then what happens? This is this here. Afterwards, if you move this towards right, is it this?
Linearly
You
decreases.
can verify this. So this is the periodic convolution for this one period we computed. Now, since it is a periodic signal, you don't need to compute it. It is a repetition. Okay. So periodic convolution, you need to find the value for only one period. And remember that integration is not from minus infinity to infinity. It is integration over one period. Okay. Okay. Any question regarding this?
Sir, if we would take this triangle as our input, then what would be the convolution of this?
If we take the triangle as the
Sir, this signal, last one which we have taken.
So
Since
you are saying are you asking the convolution of two triangular signals, pulses?
yes, sir.
So you have to
Yes.
find, you have to do the same procedure.
Sir, this signal from other side will also be shifted.
Yes, when you shift means the entire sequence is shifted, not only this pulse. It is the entire thing will be shifted.
Okay, sir.
You have to shift the entire thing. Even though we are considering the integration over one period, this interval, if you shift it, this part will move here, isn't it? So you have to consider that. Okay. And the proof of this, I am leaving this as an exercise. The proof is, please try this proof, and if you are not able to get it, I will prove it in the next class. The proof is, the property is, if xt Fourier series this is the property. Okay, sorry, it is not multiplication, it is the periodic convolution. And remember, periodic convolution I am denoting by this symbol. normal convolution is this. So when I use this symbol, it is periodic convolution. That means the integration is over one period. Okay. So this is the property. Please prove this later on. It is not that difficult. You can easily prove this. If you are not able to find it, do it. Then I can explain it in the next tutorial class. Okay. So here you can see that when you do the convolution in the time domain, in the Fourier domain, it is multiplication, isn't it? Is it the dual of the property that we discussed earlier? What is the multiplication property? Xt into yt. Is it AK convolution BK?
Yes, sir.
That is the multiplication property, and this is the convolution property, that is xt yt, it is t naught. So when this is multiplication in the it is multiplication in the time domain, it is convolution in the frequency domain or Fourier domain, and when it is convolution in the time domain, it is multiplication in the Fourier domain. So there is always a dual of all the properties. Okay.